How do you find the real roots of a quadratic equation? Imagine trying to find where a roller coaster touches the ground. That's similar to finding the roots of a quadratic equation. Roots are the points where the graph crosses the x-axis. To find these points, you need to understand the equation's structure. A quadratic equation looks like this: x squared plus bx plus c equals 0. Here, a b and c are numbers, and it is never 0. The roots are the values of that make this equation true. One of the easiest ways to find the roots is by using the quadratic formula. The formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c. I'll divide it by 2 times a to use it. First, identify the numbers of b and c from your equation. For example, if your equation is to x squared minus 3x plus 1 equals 0, then a is 2, b is negative 3, and c is 1. Next, calculate the discriminant, which is b squared minus 4 times a times c. This part tells you about the roots. If the discriminant is greater than 0, the equation has 2 different real roots. If it equals 0, there is only one real root, which is called a double root. If it's less than 0, then the roots are not real. They are complex numbers involving imaginary parts. Once you have the discriminant, plug the values into the quadratic formula. Remember to do the calculation twice, once with a plus and once with a minus. For example, take the equation squared minus 7x plus 10 equals 0. Here, a is 1, b is negative 7, and c is 10. The discriminant is negative 7 squared minus 4 times 1 times 10, which equals 49 minus 40, giving 9. Since 9 is greater than 0, you know there are 2 roots. Now find the roots by doing the calculations. X equals 7 plus or minus the square root of 9, all over 2. That simplifies to equals 7 plus 3 divided by 2, which is 5, and 7 minus 3 divided by 2, which is 2. So the roots are 5 and 2. These are the points where the parabola crosses the x-axis. Besides the quadratic formula, you can also find roots by completing the square. This method rewrites the quadratic in a perfect square form, making it easy to take the square root of both sides. It's especially useful if the quadratic is easy to factor or if you want a different approach. Another method is factorization. If the quadratic can be broken into 2 binomials, then the roots are the values of that make each binomial 0. For example, if you have x squared minus 7x plus 10, it factors into x minus 2 and x minus 5. Setting each to 0 gives you roots at 2 and 5. Remember, roots are the points where the graph of the quadratic touches or crosses the x-axis. If the roots are real, the parabola will touch or cross the x-axis at those points. If not, the parabola stays above or below the x-axis, and the roots are imaginary. So, to find the real roots of a quadratic equation, start by calculating the discriminant. Then, use the quadratic formula, completing the square or factorization, depending on what's easiest for your specific equation. Each method helps you find where the parabola hits the ground, making the concept of roots clear and simple.